Hello, Morales community. I'm Phil, head of research at Morales, and we've got a great demo for you guys today. In a second, we're going to meet Ben, a developer advocate with Axelar, and he's going to take us through an in-practice demonstration of GMP, a new cross-chain communication protocol from Axelar that gives us a lot of functionality when it comes to liquidity and other things that get us really excited here in blockchain. So without any further ado, let's welcome Ben to the stage. Ben, how are you doing today?
I'm good. Thank you for having me.
Well, it's my pleasure. And man, we're really excited to see the power of GMP in practice here today. I see that you've got some slides to share with us. So I'll get out of the way, bring those slides up, and we can get started.
Yeah, thank you. Just confirming, can you guys see my screen?
Looking good on my end.
Looking good? Okay, awesome. And Phil, I'm full screen here, so if you see any questions coming in, just cut me off, and I'm happy to answer them. But
Absolutely. I'll
yeah,
keep an
lots
eye
of
on the
good.
chat as we go.
Awesome, appreciate it. But yeah, my name is Ben Weinberg. I'm a developer advocate with the Axelar network. I'm from Toronto, Canada, so shout out to any Canadians here watching. Let's get right to it. So as Phil said, we'll be covering GMP, general message passing. But before we get into that, I want to give a brief overview of what Axelar is, why we're all here, why this matters, and then we'll get into what GMP is, and then we'll end off with the fun Uniswap demo. And for whatever time we have left, we'll do some Q&A. So let's get right to it. So what is Axelar? For those of you who are brand new to the ecosystem, in its simplest terms, it is a blockchain that connects blockchains, enabling universal Web3 interoperability. And that is a little jargony and maybe perhaps a little unclear. So let's unpack that because there's a lot going on in this sentence here. And in fact, I think the easiest way to actually see Axelar and understand what it's doing is to see a visual representation of Axelar. So if we look at it here, you can see that it operates under a hub and spoke model. And basically what we're doing is we're using Axelar, which is, remember, a blockchain that connects blockchains, to connect all these different chains. Now, this diagram is a bit outdated. We're currently at over 60 chains, I believe, that are connected via Axelar. And you can see here many different types of chains. So we got like Ethereum, Phantom, Polygon. These are examples of chains implementing what's called the Ethereum virtual machine, where you can like build contracts in Solidity. But we also have chains like Osmosis, Juno, the Cosmos Hub. These are chains from the Cosmos ecosystem. We also have like Arbitrum here at the bottom right. This is an example of a layer 2. Which we have Base as well. So you can see there's many different types of chains that are being connected here. Coming back here to what I mean by universal Web3 interoperability. It doesn't matter what type of consensus mechanism or what virtual machine your chain is running. Even if you're a virtual machine, we can connect you with Axelar. So I want to get next into this idea of general message passing. Traditionally, when we think of interoperability, we think of sending tokens from one chain to the other, typically by using wrapped tokens. And that's great and very powerful. But what's even more powerful than just the ability to send tokens between chains is the ability to send messages with a service like general message passing or GMP. So you can see here in this very, very simple example, we have a transaction going from Ethereum to Avalanche saying like, hello world. So that's an example of a simple message that you can send between two chains with Axelar. Another more powerful example you can see here on the bottom from Avalanche going to Ethereum is like SafeMint 548. And you can see why this is so powerful. It's because you can do a lot more than just like say hey to your friends on blockchain. That's not what this is for. It's for actually interacting with different functionality across contracts that might not necessarily exist on your blockchain. And that's true interoperability. It's the idea that I can call a function or send data to a function from Ethereum to Avalanche as easily as if I were sending that data to a contract that existed on Ethereum. Okay, so let's break this down and see a bit how this works. Let's say I want to send a hello world message from Ethereum to Avalanche, okay? Or I guess I have Polygon here in this example. So I will have a smart contract, which will exist on two different blockchains, like Ethereum and Polygon here. You can see at the bottom of this diagram. And then via something called the Axelar Gateway, which is a service which exists on every different chain that is connected to Axelar, which exposes several different functions, including a function called call contract with token. I can now basically, in my dApp, import this gateway contract, call this call contract with token, which will cause the gateway to emit an event. This event is then picked up by the Axelar network. Remember, Axelar is a blockchain for blockchains. It is controlled by a series of validators, 75 validators to be exact right now. And these validators will actually come to consensus about the message that was sent, this hello world message that I'm sending from Ethereum to Polygon. So once here, the Axelar network's validators come to consensus, they mark the message as approved on the gateway on the destination chain on Polygon. Then the gateway via something called a relayer will trigger a function called execute with token, which I'll have defined on my smart contract, which remember is deployed on Ethereum and Polygon. And then in this contract, I can do something like emit a message that has received the message that was passed from Ethereum via Axelar to Polygon. Any questions so far on this? I want to take a stop because that was a lot. Any questions about Axelar in general, how it works, the hub and spoke model, our definition here, or general message passing?
Well, this is maybe more of a comment than a question,
Yeah.
but just to kind of break it down even a little further for those of us who may be tuning in but aren't strictly speaking developers themselves. When we talk about a message, and this is true not only in blockchain development, but certainly true in blockchain development, we're talking about potentially instructions that trigger something on a different chain or within a different smart contract. So a message, when you hear it from the layman's perspective, oftentimes makes you think, oh, something like, Discord or even X, something where you're sending a, English phrased message, but actually it can be a lot more than that and carry a lot more power, which is why, as we'll see in a little bit, this is a lot more exciting than just, sending somebody else a message on the blockchain, though that's possible as well, of course. Back to you, Ben.
Exactly, yeah. It's a lot more than just a hello world message. It's actually interacting with functionality on different contracts, which is exactly what we're about to do here. Notice that this diagram is similar to this guy here, where we're sending hello world or calling SafeMid 5 Bored Apes. Here, what we're going to be doing today is we're actually going to be sending a message from me to Polygon. So for me, I'm going to be using the CeeLo blockchain today, one of the chains connected to Axelar, to the Uniswap router, which is deployed on Polygon. And what we're going to be doing is we're going to be using this call contract with token function. Remember, the same function which we had here, which is defined on our gateway, and we're going to call it from our dApp. We're going to be using the call contract with token function to send a token, in this case, Wrapmatic, from CeeLo to Polygon. And in addition to the token, we're also going to be sending a message. The difference is we're not sending a hello world message. We're going to be sending Uniswap Router compatible message, which is the exact input single params. Okay, so before we get too deep here, I'm actually going to pop over quickly to the Uniswap documentation to basically explain what we're going to be doing. So this exact input single params, which you see I had referenced here, this basically consists of what is that, like 7 or 8 different parameters which we pass in here. And we're going to be using it to basically pass in a specific amount of tokens into Uniswap. And based on the amount of liquidity in Uniswap, we're going to be getting an X amount of tokens out for whatever the amount of tokens is that we pass in. So in this example here, their documentation, let me make it a bit bigger so you can all see. They pass in a set amount of DAI, they receive WETH, they pay a pool fee, which you don't really have to worry about that for now. We're going to hard code this value to like 3%. The recipient of the WETH here in this transaction is going to be the message sender, which is like us, whoever's calling the function. Then we also have to set a deadline for like how long are we going to let them the pool actually take to transact here. Then we're going to specify the amount in. So like how many tokens are we actually passing into Uniswap? And based on the amount that we pass in, we're going to get an X amount of tokens out of Uniswap. And I don't worry about these last 2 parameters here for now. But then basically, once we have this giant params object, we're going to pass that into the swap router function. We're going to call exact input singles, and we're going to pass in all these different parameters. So which token are we sending in, which token are we receiving, who's receiving, and how many tokens are we passing in. So this is basically the message that we're going to be going back to here. We're going to be sending via Axelar GMP from CeeLo to Polygon, and then we're going to actually be conducting the swap on Polygon. Cool.
Perfect. Let's see it in action.
Let's get to it. So we have some starter code here. I'm going to walk you guys through it quickly because there's a lot going on before we actually start implementing some of what I just described. So we have our contract here called Interchain DeFi. And you can see right off the top here, we have 2 tokens with their addresses hard-coded. These are the tokens that we're going to be actually swapping between. Okay, notice how I specified Mumbai here because we're going to actually, remember, be conducting the swap on Polygon Mumbai, not on CeeLo. We're going to be triggering the transaction from CeeLo and sending the asset from there. The swap itself is going to be on Polygon, which means we need to specify the token addresses as they exist on Polygon. So we're going to be swapping in Rapmatic, and we're going to be receiving WETH on Polygon. Okay. On line 16 here, we have a public variable called the gas service. And you notice here in our constructor, we're passing in addition to our gateway. Remember our gateway from here. This is the contract which Axelar has across all different chains, which exposes different functionality, including the call contract with token, which we use to basically trigger the cross-chain transaction. In addition to the gateway, we have our gas service, which we pass in here, and we have publicly available here on line 16. So what is that? I haven't touched on this yet. If we think about what we're trying to do here, we're sending a transaction from CeeLo via Axelar. Remember, Axelar is a blockchain of blockchains to Polygon. And what does that mean? It means that we need 3 different tokens. Why? We need to pay the gas on CeeLo. We need to pay the gas on Axelar, which is a blockchain. And we need to pay the gas on Polygon, of course. And I don't know about you guys, but I don't want to have to worry about holding 3 different native tokens, or tokens, I should say, for each cross-chain transaction that I want to make, right? And that's where the gas service comes in. It exists to make user experience and developer experience, frankly, much easier. And what does it do? It basically allows you, as the person sending the transaction, to pay for the entire transaction in the token of the source chain. Okay?
Oh, interesting. So really all you have to have then is gas on CeeLo in order to be able to process the full transaction, taking care of the gas on Axelar and on the destination chain. Am I correct?
Exactly. So just to be clear, though, the money is still coming out of our pocket. Like, we're not being subsidized here, but we are able to pay the entire cost in the token of the source chain, just so I don't have to worry about balancing 3 different assets every time I want to make a transaction. That's basically what the gas service is going to be doing for us, and we'll be using it in this demo. Okay, so we have it publicly defined here. And in our constructor, like I said, these are the only 2 parameters we need to pass in. Like, what is the address of the gateway on both CeeLo and Polygon, because that's where we're going to be deploying this contract, and what is the address of the gas service. The other thing we have here, I kind of glossed over, is the address of the Uniswap router. This I got straight from Uniswap's documentation. This is the address of the router on Polygon Mumbai. Remember, where we're going to be conducting the swap. And again, what we're doing here, we're sending Rapmatic from CeeLo via Axelar to Polygon Mumbai, and plus a message to the router to conduct a swap. Okay, so this is the magic function, interchain swap, that we're going to be using to really trigger this entire transaction. You can see here it takes 4 different parameters. The first one is the destination chain. So, hey, which chain are we going to? This is going to be Polygon. This is the name of our destination chain. What is the destination contract address? So once we get to Polygon, where are we going there? And that is going to be this contract. Remember, this contract is going to be deployed on both chains. So if we go back to our little demo here, or our little diagram, I should say, we end up where? At our destination, at our DApp on our destination chain, which is going to be this contract. Then what is the symbol of the token we're going to be sending? Because remember, we're sending a token from chain A to chain B, so that's going to be Rapmatic. And then what is the amount of the tokens that we're going to be sending? So any questions about these 4 parameters here that we're going to be sending in? So it's where we're going, which chain we're going, where on that chain are we going, And then what is the symbol and the amount of the token that we're sending. Cool. So first thing we have here is a little require message, a require statement. Basically what we're saying here is, hey, make sure that the message value, in other words, the amount of tokens that we're sending with this function call, native tokens that is greater than 0. If it is 0, if we forgot to send tokens, then we have to revert, because we're going to actually need that message value to be paid to our gas service to actually handle the cost of the interchain transaction. Next, we set the pool fee. This is what I referred to before from Uniswap they have. So this pool fee right here, I set 3,000 because I think I remember seeing that. Yeah, they have it here in their documentation, basically a pool fee of 0.3%.
Now, it sounded like you said that the gas service is paid out of the amount that you specify in the value line there, the gas payment, right next to where you had gas payment required. How do I know that the amount that I'm putting in there is enough to cover the gas? Or frankly, how do I know what the gas is going to be over
That's
on
a great
Polygon?
question. So we don't have it implemented here. For this demo, I'm just going to pass in a relatively high amount. But in production, what you'd want to do, we have an SDK, and that basically SDK allows you to call a function called estimate gas fee, and that will estimate the exact amount they need to pass for the interchain transaction. Now, you'll see once I implement the actual function for paying the gas, we will also be able to specify a refund address. So let's say it cost me 0.1 ETH to send or CELO to send the transaction, and I send like 5 just because I can. What will happen is any surplus that is sent will be refunded to a specified address, and I'll just specify that address as of my own, just in case we do send too much. But yeah, it's a great question. We do actually have functionality to estimate the exact amount that we have to pass in.
Perfect.
Yeah, moving on. So we have our pool fee here that we just hard code. Next, we actually have our first interaction with our gateway contract. Remember, the gateway is what we passed in up here in our constructor to Axelar executable, which I'll touch on Axelar executable in a bit. But notice here we're inheriting from it. Gateway is publicly defined there, so we have access to our gateway contract. And what we're going to do here is we're going to call a function called token addresses. And what this does is it takes in the symbol of the token that we're going to be passing in, which is Wrapmatic. That's a token we're sending from CELO to Polygon. So it takes a symbol and spits out the address of that token, because to actually interact with the token, we're going to need its address, not its symbol. So we say Gateway's asking us like, hey, what's the symbol of the token? Okay, here's the address that you need on whatever the blockchain is that you're using it on. So now we have our address of our Wrapmatic token on CELO. Remember, this is all going to be happening on the source chain. Now with our token address, we can call transfer from, so which is standard ERC20 function will basically take the tokens from my EOA, from my wallet, and send it to, in this case, this address. Okay, and and the amount is how many tokens we're sending. Next, we're actually going to be approving the gateway address to spend tokens on our behalf. Okay, so let me comment this out. Where are we right now? We've called the interchain swap. We've said, hey, is there enough gas or is there even any gas being passed in? If none, revert. If any gas has been passed in, we're good. Specify the pool fee, grab the address of the token, and then transfer the tokens from my address to this contract, to this interchain DeFi contract. And then once interchain DeFi has these tokens, which it took from my account, it will approve the gateway. Remember, Axelar's gateway to basically spend tokens on its behalf. And that's where we are now. Are we good up till this point?
Absolutely. Tracking so far.
Awesome. Next thing we want to do is actually set up our message for Uniswap. So if this looks familiar, that is because I got it straight from their docs here. Remember the token in, the token out, the pool fee, the recipient, all the Uniswap parameters that they need. So I basically took exactly what they had from there and stuck it in here. And the difference is that in this case, we're taking our token in. What we're swapping into Uniswap is going to be our Wrapmatic. Notice how it's the Wrapmatic address on Mumbai. You'll see why shortly, because the swap is actually going to be taking place on Polygon Mumbai. So the token in is going to be arithmetic. The token out is going to be WETH. That's what we're getting out of Uniswap. We pass in the pool fee, which we hard-coded here on line 38. The recipient is going to be my address. I want to receive these tokens. Our deadline is going to be now plus 1 day. I'm giving it a long time just for demo's sake, so we don't run into any issues here. And then the amount in is going to be the amount that we specified here on line 34 as our parameter. And now we have our Uniswap message. Great. So once we actually call this function, we have received the token on this contract. We have now specified our parameters for Uniswap. But we're not done. We actually have to go through now this whole process. We actually have to run this call contract with token function to trigger the gateway to emit the event, to go through Axelar, to eventually get sent to our destination chain, right? So let's do that now. Well, the first thing we want to do is our swap params. This is an issue. Why? Yes, this is the message that we're going to be sending from CeeLo to Polygon, but Axelar GMP can't handle this random data type of exact input singles param. What it can handle is a type bytes. This is the type that we need to actually specify as our Axelar GMP message. So let's create a new variable called encoded swap payload. And the way we actually transform this data type of exact input single param to bytes is by simply calling ABI encode, and then we're going to encode our, just copy and paste it, swap params. Great. So at this point, we now have this entire object in a type bytes that Axelar can handle. And now let's actually start to interact with our gateway and our gas service. So the first thing we want to do is, like we said before, actually pay for the gas of the entire interchain transaction. Okay. So we're going to call gas service, and then we're going to call this kind of mouthful of a function, pay native gas for contract call with token. So as the name suggests, we're paying for the transaction in the native gas token, and the transaction type is going to be a call with token type. So we have two options in Axelar. You can basically send a cross-chain transaction without a token, or you can send it with a token. In this case, we are sending it with a token, which is WETH. So what are we going to pass in here? First, we're going to pass in the message value to actually pay for the transaction. And then this pay native gas for contract call with token is going to require several different parameters, including who is paying, who's this gas actually being paid for? Well, it's going to be for this interchain DeFi contract. Where is the transaction going? It's going to the destination chain. Where on the destination chain? Well, destination contract address. Basically, all the parameters which we specified up top, we're just going to be passing in here. What is the message that we're going to be sending? It is not swap params. It's going to be the encoded swap params. Remember, because it expects to type bytes. Then what is the symbol of the token that we're sending? What is the amount of the token that we're sending? And last but not least, remember you actually asked about it, about the gas amount, and I was talking about the refund. Well, which address do we want to be refunded to if we send way too much gas and there's a surplus? I'm just going to specify the message sender, like just send it back to me.
Now that would be the address on the origin chain that we're receiving any refund in. Am I correct?
Yes, exactly. Looks like I have a syntax error here.
While you're taking a look at that, I'll just kind of re-break this down for anybody who's following along and maybe seeing this for the very first time. So we have a request for Uniswap that we've taken in the standard Uniswap form and prepared that. That's our message that we're going to use like the Axelar rails to send basically through two networks in order to process our request. So that's what we're preparing to do right now. We've encoded that in order for it to be read properly by the Axelar protocol. And we're simply specifying all of the other parameters in order to properly send that message to the destination chain, which in this case is Polygon, like we've been saying here.
Exactly. So at this point, once we call interchain swap, we'll have gone through this whole functionality, which is taking the token from me, holding it in interchain DeFi, constructing our message, encoding it, and now paying for the cost of our multi-chain transaction. Now, there's one more thing we have to do, which is what we have referenced here in this diagram. Actually talk to our gateway contract to trigger this multi-chain transaction. Okay? And for that, we have to go gateway, and I've literally just copied and pasted it from the slide, call contract with token. And once this is called, it will actually trigger our transaction to go from Celo via Axelar to Polygon. And this wouldn't be possible unless we also paid for our cost of this transaction. So what's this going to take? It's going to take in similar functionality to the gas service. It wants to know the destination chain, where's the transaction going, destination contract address, where on the destination chain is the transaction going to, what is the message that we're sending, so that's our line 57, encoded swap payload, remember, which is an encoding of this swap params object, and then the symbol of the token that we're sending and the amount of the token that we're sending. And that is it. Once we actually call this function, we will have successfully paid for and triggered an interchain transaction. So going back to this diagram, as soon as I call this function, we will trigger this call contract with token function. The gateway will emit the event. We'll go to the Axelar network. The Axelar network will come to consensus, mark the message as approved to the gateway on the destination chain, but we're not done, because once the gateway now has an approved message on our destination chain, we're actually gonna have to do something with this message. It's not enough to just send it, we actually have to handle it. And that's where we get to step 4, our execute with token function. This is gonna be triggered automatically by a relayer on the destination chain. So you'll see we have this, the function signature already written out. Execute with token, you see this matches step 4 here. There are other parameters here which we don't have to worry about for now. The only two which we'll actually need are the payload and the amount. So let's actually write out this function, okay? First thing we're gonna wanna do is deal with this payload. Can anyone take a guess what the payload is that we're gonna be receiving in this function call?
Any guesses in the chat?
Yeah. No pressure.
Okay, that's enough time. Go ahead and reveal it to us, Ben.
What the payload is, it's the message that we're sending from Celo to Polygon. This is how we receive the message on the other end. Now, what is the message? The message is this swap params, right? But remember, before we actually sent the swap params, we encoded it. Now, this is great because when it was of type bytes, we were able to send it through the Axelar network. But once we now received this on Polygon, we don't want to deal with type bytes. We want to deal with the Uniswap object, the exact input single params type. So I'm actually just going to copy and paste this right here. And let's call it decoded GMP message. Now, how do we get this param out of type bytes? We call ABI decode, the opposite of ABI encode. And we're going to be decoding, what are we going to be decoding? The payload, line 82. And we need to tell it, like, hey, what type are we going to be decoding it to? Well, it's going to be this exact input single params type. So now, once our execute with token function gets hit on our Polygon destination chain, the payload will come in. We're going to say, hey, we don't want to type bytes. We want to type exact input single params. Apologies for the mouthful. So we decode it, and now we have this variable with the exact data type that we want. So now we're basically done here. There's just 2 more steps here. With our by token here, which we defined up top, if you recall, we're going to want to basically approve the Uniswap swap router to actually handle these tokens on our behalf. And how many tokens are we approving? We're approving whatever the amount is that we received. So on the execute with token function, which is defined on our Axelar executable up here, let me actually just show you guys all the parameters which it takes, because they're very useful ones. Command ID, I'll actually skip over for now. That's beyond the scope of this. But what we take in is the source chain. So, hey, what chain has this interchain transaction just come from? For us, it's going to be Celo. That's where we're sending the transaction from. We don't actually care where the transaction is coming from for the sake of this example. That's why I left this blank here for now, but it's good for you to know that you kind of get this data right out of the box. So we get the name of the chain where the transaction has come from, the address on the source chain which this transaction has come from, the payload, which is our GMP message. This is one that we actually did use here. The symbol of the token that was sent, which we also doesn't really matter for us, and the amount of the token that was sent. This one does matter for us. So now we decode our GMP message to receive the exact input single param data type. Remember, this is the Uniswap data type that we need. We approve the swap router on Polygon to handle the amount of tokens that we need. And the last thing we're going to want to do, I'm actually going to take this straight out of the Uniswap docs, is called swap router, exact input singles, and param. This is basically going to actually trigger the swap on Uniswap. And we don't want param. We want to actually pass in the decoded GMP message as our data type. And that is it. Any questions here before we fire this up to see if it works?
I think we're following so far. This is very exciting. So essentially, you could continue to send these requests all day long from your source chain and have it finalize on your destination chain. Now, is there ever a situation where, or maybe a better way to ask this is, because we know that the composition of the liquidity pools on the destination chain are constantly in flux. Is there a sense that I kind of think I know what you're going to answer here, but I'll ask it this way anyway. Is there a sense that we don't fully know what we're going to end up with in terms of amount on the destination chain? Or is there a fail-safe where we can define that in some way?
So yeah, so two ways to look at this. So in terms of how many tokens we're going to end up with, we're going to end up with however many what tokens are we sending? Wrapmatic that we're sending, right? So we're going to get how many tokens we send. In terms of the swap, we don't know how many tokens we're going to swap out for the tokens that we swapped in. But that's not an Axelar thing. That's a Uniswap thing. So remember what we're doing here in this example. We're basically telling the Uniswap protocol, like, hey, I'm going to give you this amount of tokens in, and based on however much liquidity you have, based on how the AMM works, you're going to give me a certain amount of tokens out. I don't know how many tokens you're going to get, but it's in proportion to how many tokens I put in. You'll notice that there is the second last parameter here. I can actually specify an amount out minimum, which is saying, like, don't do the swap unless I get at least, let's say, 5 tokens out.
So that's our fail-safe right there. We can put in.
This is all on the Uniswap side. So I could have specified that, in my GMP message as well. I didn't, just for simplicity's sake. Uniswap has the inverse of this as well, where it can be like, hey, I want these amount of tokens out. How many tokens do I have to put in? And in that case, you'll actually know exactly how many tokens you're going to get out. But this is all more how Uniswap works.
Got also a good question in the chat here. Now, I know, Ben, you already basically answered this, but let's go over it for review here. The question is, do we pay gas on both chains? And I'll leave it to you. I already know what you're going to say, though.
So the answer is yes. The gas service, remember, which we interacted with right here on line 60, basically allowed you to pay for the entire transaction on both CELO, Axelar, and Polygon on the CELO chain. In the token of the CELO chain, I should say. That doesn't mean that Axelar covers the gas for us. We're not being subsidized here. The money's still coming out of our pocket. There is still the execution cost, which we're paying for. With the executions taking place on Polygon, so we're paying the gas on Polygon, but we don't have to actually worry about holding Matic in our wallet, if that makes sense. We still pay in the CELO token because that's our source chain, but we're, at the end of the day, still footing the bill for this one.
Absolutely. And Don, to maybe answer your question a different way, yes, you're paying gas in both chains. Now, if your question was, do I need to fund all chains with gas independently before performing these steps? The answer is no, because the gas service is going to take care of that for you, so long as you have enough value of funds to cover the gas on your source chain.
Exactly. Any more questions, let me know. You'll notice here in our CLI, the contract compiled. So happy with that. And we're going to actually try interact with this thing live on our 2 blockchains here.
Let's do it. That sounds great.
Awesome. So
Now,
we're going to
guys,
go.
of course, we're processing a testnet transaction today. And just keep in mind when you're using testnet, the composition of the liquidity pools is, of course, different than the liquidity pools on the mainnet. And so if you're looking for a value output before testing, you would actually need to, or when testing, you would actually need to use the mainnet rather than the testnet. Just something to keep in mind when you're testing this yourself.
Exactly, yeah. And I'll make this code available for all you guys. You'll notice we do have some stuff going on beyond here. We have our deploy scripts for CeeLo and from Mumbai. I'm not going to walk through this now, but I will interact with it. So let's go hard hat, run scripts, deploy Mumbai, network Polygon. And this should spit out an address for us right here on Polygon Mumbai. Is this, you guys can all see this? Oh, too small.
Yeah, it looks good. I mean, if you could zoom in just a little bit, it might help.
There we go.
Yeah, well, that's
Better?
even better.
Okay. I'm now running the same script, but not for Mumbai this time. I'm running it for CeeLo, and hopefully, yep, we got our CeeLo address and our Mumbai address. Great. So if I were to actually go, actually, let's interact with it first, then I'll show it to you on the Explorer. So what are we going to do? We're going to call this interchain swap function. Remember the first function that we actually wrote up here. So we're going to do this via the hard hat console. We could do this through Remix. There's many different ways we can do it. I prefer the hard hat console. I think it's pretty straightforward for this. So let's actually write this up. Contract. I'm going to get an Ethos contract factory object for interchain DeFi. Interchain DeFi is what I called this contract. Now we're going to go contract. We're going to attach our live address on CeeLo to this contract factory. Now we actually have a contract, an instance of our contract on CeeLo that we can interact with. So let's say I want to call this public gas service variable that we defined on line 16. I can go gas service, and it should spit out the value for this variable in storage. And it is, so that's good. Now let's actually do something more interesting. Let's actually call this interchain swap function. So we're going to go await contract interchain swap, and now we're going to have to pass in these 4 parameters. So the first one is the destination chain. So where are we going? Well, we're going to Polygon. What is the address on the destination chain that we're going to? Well, we're going to our address of this whole contract on Polygon, which we deployed here. So 0xF8B, yada, yada, yada. So I'm going to paste that right in. Next param is the symbol. Which token are we sending? We're going to be sending the Raphmatic token. This is going to be the token that, remember, on line 47, we're going to be swapping in to the Uniswap Router. And then how many tokens are we going to be sending? Let's send in, actually copied and pasted it here, 0.1 Matic, which is 1 with 17 zeros. And now this will fail. Why? Anyone want to take a guess why? We're missing one thing here. The clue is line 36 in our code.
Oh, we didn't specify enough to pay the gas.
Exactly. We're not paying any gas right now. So to do that, we have to pass in a value. And I'm just going to pass in a value of 1 CeeLo here. Hopefully I have enough in my wallet to cover this. But that is it. Once I hit enter here, we should get a transaction hash, and we do. So you see this transaction has been executed. We have our hash right here. So if I go to the CeeLo testnet explorer, I can paste in this transaction hash. And I see 12 seconds ago, this transaction was executed. And this is great. And the CeeLo Explorer is probably familiar to anyone who's ever used like Etherscan before. I think it's built by the same team. It looks just like it. But what if it'd be nice if we had something more, right? We're doing a lot more than just a transaction on CeeLo. We're actually, as we saw here, taking the transaction on CeeLo. This is only one part, sending it to Axelar and then receiving it on Polygon. Fortunately, we have our Axelar scan block explorer, which can show the entire interchain transaction taking place. So let me make this dark mode so I don't burn your eyes. This is the Axelar scan block explorer. This is the testnet version, so that these stats are relevant to testnet, not to the actual mainnet. Could do a whole talk on Axelar scan block explorer. It's pretty awesome. I'll I'll even show you the mainnet one as well, so you can see the most up-to-date stats on Axelar. So you see we're at 64 connected blockchains right now, 75 validators maintaining the Axelar chain itself. Notice this diagram here is much more going on here than in the simpler one that I shared earlier in the PowerPoint. You can see all the different chains connected to Axelar, some of the transactions that are going through Axelar, volume which we've done. So I'm going to flip back here to the testnet Axelar scan. I'm actually just going to paste in the transaction hash, the same hash that I pasted in here into CeeLo. I'm going to throw it right into Axelar scan. Okay. In a second, we should see the actual interchain or multi-chain transaction taking place. Or already went through pretty quickly this time, from CeeLo on Polygon. So you can see CeeLo via Axelar to Polygon. This is actually probably a much clearer way of seeing it than in the diagram I had on the PowerPoint. But what's really cool here, let me make it bigger so you guys can see. You can see the exact step-by-step of the transaction. So I can see if I click on here, the little CeeLo icon, it takes me right to the transaction hash on the native CeeLo block explorer. See, it took me to the exact same page I was here before. You can see the gas paid transaction. I can even see the little X here, the transaction being confirmed on the Axelar network itself. Remember, Axelar is itself a blockchain. Next step, you can see the transaction getting marked as approved on Polygon. So you see, notice here I'm on the Mumbai Polygon scan explorer now. And last, but certainly not least, I can actually see the final step of the interchain or the multi-chain transaction, which is the execution on the Polygon scan explorer. So if I click on here, or I can even just click on the transaction hash, it takes me right to the Polygon scan explorer, and I can see our transaction actually taking place. I can see the Rapmatic coming in, the WETH coming out. It's a very, very tiny amount of WETH being sent to this, which is my address. But it is being sent nonetheless. The swap is taking place, just in a very small amount. And that is it. You can see the transaction has successfully executed in coordination with the Uniswap router on Polygon scan, and the transaction originated from CeeLo.
That's beautiful.
Yeah.
And I just wanted to add here, a lot of you who are watching right now are developers, and you probably are already thinking what I'm about to say. But for those of you who are maybe interested in development or interested in cross-chain development and in watching this for the first time, what we want to imagine here is that everything that we just created is a UI function of your dApp. So your user has funds on CeeLo, and he wants something else over on Polygon. And through what we saw here, you can build an experience for them where they go in, they say this amount and give me this asset on this other chain. And then like that, they're able to verify it through this block explorer, through the Axelar block explorer, and then of course have their tokens on the destination chain without having to use a bridge at all. All they're performing is a swap and ending up with those tokens on the other chain. Is of course the most exciting thing about what we're looking at right now. Just wanted to add that in there, Ben.
Yeah, for sure. Just to wrap up here with some final few slides. If this interested any of you and you guys want to play around with this more, other examples we have on our left, we have QR code to a YouTube series that we have, a series of tutorials similar to this one, explaining some simpler and more advanced examples on using Axelar. On the right, we have a link to our GitHub repo, which is just full of amazing examples using Axelar. So like sending NFTs between chains, sending just simple hello world messages between chains. Also examples for Cosmos-based transactions. This was obviously EVM to EVM. I want to get this example also as well added to that repository as well, so you guys can take a look at that there. So highly encourage any of you guys to take a look at these two links. They're super helpful. It's how I learned to do this. And thank you very much for your time. My name is Ben. You guys reach out to me at any time. I'm here, Telegram. And yeah.
Well, thank you so much, Ben, for that awesome demo. And if you guys are interested in other demos like this, we had one with Idris, also a team member over at Axelar. And with him, we went over the interchain token service, which is equally powerful and equally interesting, but in a completely different way. So I encourage you to check out that if you're interested in this type of tech. Now, that said, we are pushing a lot of brand new dev content to this channel this year. So if you're interested in more content like this, hit the like and subscribe so that you don't miss anything like this, and so that we can see you again in the chat asking excellent questions and learning more about this powerful new technology with us. Ben, did you have anything else for our viewers today before we wrap it up?
No, just thanks for taking the time. If you want, you can contact me whenever. I strongly encourage anyone who's interested to learn more about this to check out the Axelar examples repository to check out our YouTube page, and then of course our documentation. Join us on Discord to be a part of the community. And yeah, looking forward to chatting with each and every one of you.
Amazing, guys. Well, we'll see everybody in the next video. And remember, blockchain, DeFi, and crypto is the future. And Morales, along with our partners like Axelar, are leading the way. We'll see everybody later on.